Good morning to all. So, in last class what we have seen the decision tree in generalization of the decision tree. In today's class we will study some specific decision tree. So, one of the famous decision tree is the CART, okay, that is classification and regression tree. So, it is a binary tree, that means in earlier whatever we use for the partitioning or splitting an attribute, if there are multiple values. So, we can go with the multiple branching, but here is restricted to only the two branches, that is the binary tree. So, CART is a binary tree and we need the exhaustive search to find the which one will be the best split. Let us say we have the three values like in the car example or the marital status example. So, single, divorce and married. So, but we need to find the only the we can go with the binary partition. So, you can club with single with divorce and then married is separate, and then we will find the which one is the best and then we go with. So, whatever in earlier we computed the impurity, we computed the entropy, but here we will compute something different, but the idea is again the decision tree is like whatever the basic idea of the decision tree, that there will be a terminal node will be identified by the class level, and intermediate node is nothing but the split conditions and so on, attributes values based on that split condition. So, now how do you get the best split? So, this is the formula here. What they are doing it is like if you have a node here and then as I said it can have maximum the two branches. So, let us say left side is one branch and then we have the right side another branch, okay. We cannot have more than that. Now, we will find whether this split is the best or not. What we do? We will find the maximum separation between this left side node and the right side node across the classes. So, that is the formula here. So, what is the S? S is the criterion and T is the node here. So, at the current node is T here. Now, what we do is we will find this equation here. This equation is not very difficult, it is very simple. What is first we identify this one and this one, okay. Let me tell you the from the beginning what is that. Twice into PL into PR. What is PL? PL is the probability that an object in the left subtree. So, that is what how many object it is in the left subtree by divided by the total size of the data set. So, that is something called the PL. Similarly, there will be R, PR. So, this is how many object, that is cardinality of R divided by the total dating data set. So, that is the PL and PR. And then now we need to understand this term, this as I said this is the separation between the left subtree and the right subtree. What is that P, C, J, T, L, and over the classes, if there are two classes obviously we will have the two terms, if there are three classes we will have the three terms here. What is that? It is here. So, object with class C j in the left subtree divided by the object in the node T. So, that means how many object here we can count, how many object with class C 1 divided by number of object at the node here. So, if it is 100 and here is 60 and this is 40, out of the 60 how many objects belongs to class C 1. So, that is the something how many objects with class C 1 divided by 100 not 60. Similarly, how many object on the right side. So, if it is let us say out of C 1 say out of 60 let us say 20. So, then 20 by 100 minus what is that P C J T, again the same class on the right subtree. So, it is basically it is comparing on the same class how many are in the left subtree, how many are on the right subtree, and then you take sum of over this one. So, that will give you the this entire the objective what is called is the criterion function, and wherever we will get the maximum separation, that is this is the separation, okay, maximum separation. So, that particular attribute split we will consider. So, now what we do it, we will work out with one example here. Let us say we have a data set here, this is one example we have taken from some reference book. So, we have two attributes, name is say 3 attributes, name, gender, height and then class level. Now, what is the task? Forget the name. So, whether we choose the attribute gender or height. So, now if you take the attribute gender, then we will have the 2 split, that is very easy, okay, because it has the binary. So, there is no problem. So, one will be male, another will be female, and then we count how many object is here. So, you count male 1, 2, 3, 4, 5, I think this will be also 6. Okay. So, this side there will be, and then this side there will be 9. Then what we have to do? We have to count the, so we have to find the best split, and similarly what we can do it now here we can use height is another attribute, height is another attribute, and then we will have the only the 2 split. But here we have the many values, then what we should do? We will take the range, say starting from somewhere is 1.6 to 2.2, somewhere is 2.2. So, we can make a split like 1.6 is 1, 1.7, 1.8, and then 1.9, and then 2, and then let us say 2.2 is not required. Okay. So, now what you do it? So, we will put on the left side, here is if it is less than 1.6 height, and this side is greater than equal to 1.6. Similarly, we do it the same height, one side is less than 1.7, on the right side will greater than 1.7, and for each case we have to compute that split function, okay, that criterion function we have to compute, and then wherever we will get the maximum, so that attribute we will take for partitioning. Now, first as I said is you have to compute that function, that is for the gender, and then height, and height is having for this one we have to compute, and so on and so on. So, it is very easy to compute for the gender. Should we go with comparing computing gender, let us say here. So, how many attributes you have here? Here how many object you have? 6, and here 9. Now, what is that formula? If you go back here, so this is the formula here. First you have to compute PL and PR, and then you compute the individual. How many classes there are? So, let us say here how many classes. So, you have to compute PL. What will be the PL? PL will be 6 by 15, and what will be the PR? It will be 9 by 16, and then there is a term is something called, so PL is something what, how many object in this left subtree divided by total training size. So, therefore, 16 by 15 is the how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So, that is PL equal to 6 by 15, okay, and then PR equal to 9 by 16. Oh, sorry, so 9 by 15. So, then another term you have here, that is PCJ at the node T, that means PCJ at the node T. What you have to do here? How many out of this one? This will be 15, because total number of node here is 15 and data set is also 15, and Cj is what are the classes here? You have 3 classes. So, 3 classes, then you say is the for first case you see is P of C sort at the given node T. What will be this value? So, we are talking on the left side. So, left side is this is tall, this is medium, this is short, this is tall, this is tall, this is medium. So, it will be 1. So, then we will compute 1 by 15, 1, this is no. So, 1 by 15. Now, 1 by 15, and then you have to compute P C sort R, 1 by Cj P Cj Cj TL. Okay. So, 1 by 15, and next what you have to do? C sort on the right side. So, out of 9, how many objects belongs to class sort? So, this is sort 1, then this is medium, this is sort 2, this is 3. So, 3 by 15. Now, you subtract it and you take the absolute value. So, you will get 2 by 15. Okay. So, then we will get the first is it was 6 by 15 into 9 by 15 into 2, and then the term will have 2 by 15 plus, then we compute the another value for